All right, you guys, our final example problem involving applications of sine, cosine, and tangent. So this one involves a plane. I did my best drawing a plane. I know that's a really pathetic and sad looking plane. But again, I'm a mathematician, I'm not an artist, so I tried. But anyway, so after flying at an altitude of 9 kilometers, a plane starts to descend when its ground distance from the landing field is 175 kilometers. Okay, so before we talk about the rest of this, first of all, an altitude of something tells you how high up in the air you are. Okay, usually if you've ever been on a plane, the pilot will at some point tell you, like, it is now safe to take off your seatbelt. We are flying at this altitude, which means that's how far up above the ground you are. It's kind of weird when they tell you that because then you realize how high up you are. But anyway, so altitude always refers to how high up an object is. So the altitude of the plane is 9 kilometers before it's trying to land, okay? So an airplane starts to descend. So that means it starts to head downward toward the landing field. Okay, that's where it's going to land. An airplane starts to descend when its ground distance from the landing field is 175 kilometers. Okay, so the wording's a little tricky. Okay, so the ground distance. Ground distance mean, well, this is the horizontal distance the plane is from where it currently is to the landing field. So I drop down this vertical line to represent, well, this is where the plane would be currently if it was on the ground. And the distance from that spot to the landing field, this is called the ground distance. Okay, so the ground distance, so the horizontal distance if the plane was on the ground to the landing field is 175 kilometers. Okay, so that is what that is referring to, which I know the wording's a little strange, but that's what it says. Okay, it says, what is the angle of depression? So we're dealing with an angle of depression this time. So this problem is about an angle of depression. What is the angle of depression from this portion of the flight, or for this portion of the flight? Okay, so basically we want to know what is the angle that the plane is using to descend toward the landing field. Pretty much is what we're asking. Okay, so this horizontal line here represents the line that the plane is traveling when it's traveling through the air. And then when the plane starts to descend, or when it starts to land, it goes from being horizontal and then headed downward. So it's creating an angle of depression because it's created by a horizontal line and a point of sight below the line, or a line that is below the horizontal line. Okay, so this right here is our angle of depression, and that is what we're solving for. So that is x. Okay, which if you guys see, yet again, I have formed a right triangle. Okay, you're going to have to form a right triangle to solve these problems. Okay, so here's my right triangle in the problem. Okay, I have two sides given to me in my triangle. I have a 9 kilometer and a 175 kilometer, but the only other thing I need in order to solve is either an angle that I'm solving for or an angle that I'm given. Well, currently, the only angle I have in my triangle is the right angle. Okay, so this is again when we have to use the angle of depression to give us another angle in the triangle. Okay, which if you guys see here, what letter do you guys see? I see kind of a Z shape. And what is that Z angle called? They are called alternate interior angles, and don't forget, alternate interior angles are congruent. Okay, so these two angles are equivalent. So if that is x degrees, this one is x degrees. Okay, so the actual angle I'm solving for is this one right here, which I know I kind of marked over what this says. This says 175 kilometers. Okay, so this is the angle that I'm starting from in my triangle. And from here, let's just solve. All right, so the 9 kilometers is the side of the triangle that's directly across from the angle I'm solving for, which means it is the opposite side. The 175 kilometers, which I know I wrote over, now it's hard to see, this is a side right next to my angle that is not the hypotenuse, because the hypotenuse is the side across from the right angle. So what side is the 175 kilometer? Wholly to the hot dog, that would be the adjacent side. Okay, so I have an opposite and an adjacent. I'm doing it again. Stop with the stuttering on the adjacent, Miss Long. But anyways, the opposite and the adjacent. Which trig function has opposite and adjacent? That would be tangent. We're going to be using tangent, so let's do it, you guys. So tangent of my angle, which I don't know the angle, that's what I'm solving for. So x, we're solving for the angle of depression. Okay, and tangent will equal the opposite side over the adjacent. Well, the opposite side is the 9 kilometers. The adjacent side is the ground distance, which is the 175 kilometers. All right, and from here we just solve for x. Okay, don't forget whenever you're solving for the angle in a right triangle, that is when an inverse trig function will appear, which if you guys notice, my x is currently trapped inside of the tangent, and I want it to get out of the tangent. Okay, so what I need to do to cancel out the tangent or to move tangent to the other side of my equation is by taking the inverse tangent of both sides of my equation. Okay, so I'm going to put this part right in here. So tangent of x. And then I'm going to put this part right in here. So it's going to be 9 over 175. Or 175. Okay. All right, so the inverse tangent and the tangent will cancel each other out. So I'm left with x equals the inverse tangent of 9 over 175. Okay, which we're solving for an angle of depression. So what do you think my units will end up being? Well, if it was a unit of length, it would be kilometers, but we're solving for an angle. So my unit of measure is degrees. So just keep that in mind. All right, last step. Let's type this bad boy into our calculator. Let's do it. All right, don't forget, make sure your calculator's in degrees, which my calculator is. So I'm going to hit second tangent to get the inverse tangent, and then 9 divided by 175. So the angle of depression when the airplane is descending, let's just round to the nearest whole degree. That 0.9 will bump up my 2 degrees to 3 degrees. So the plane is descending very gradually, which is a good thing. In my picture, it looks like the plane is just going to kind of crash into the runway. Okay, usually when airplanes land, you do it gradually, so you don't just like crash and burn up and die on the landing field. That'd be a little depressing. We're all trying to get to our destination, okay? So, sorry guys. Let me plug in my computer before it dies on me. Sorry. Okay. But anyway, so it's going to gradually descend until it hits the 3 degrees. Okay. So, again, you can also type this on Desmos. Now my cord's all in the way. Good golly. Okay, anyways, I'm going to go to desmos.com now and show you get the same thing. So I'm going to type, sorry, those are the answers to the problem. But anyway, so tangent, inverse tangent, I'm going to say tangent. I'm going to say raised to the negative 1, even though we're not technically raising it to the negative 1, of 9 over 175. And if you see, we get the same thing. Look at that. You can also get to inverse tangent by clicking on the keyboard, clicking on the function button, and clicking on inverse tangent. Well, I hope you guys have had a blast solving these. I think these problems are really fun. And yeah, that's it. So way to go, you guys.